In this video, we want to talk about partial fractions decomposition for functions that their denominator contains repeated irreducible quadratic factors. Let us start by this example. x4 plus x2 plus 1 over x plus 2 times x to the 2 plus 1 times x to the 2 plus 4 all to the 2. Attention, in the denominator we have this linear factor. We have this quadratic factor, which is irreducible, but we have this quadratic factor x to the 2 plus 4, but attention, it is raised to the power of 2. So it is a repeated irreducible quadratic factor. How we can write the partial fraction form for such rational functions? First, for this part, which is a linear factor, as usual, we just put this as a partial fraction, and in the numerator we just put a. This one is a quadratic factor, irreducible quadratic factor. Why we say it's irreducible? Because we cannot factor x to the 2 plus 1. So we have this partial fraction, x to the 2 plus 1 in the denominator. But because this is a quadratic factor, in the numerator we put px plus c. For x to the 2 plus 4 also we have this, and in the numerator we put dx plus e. But attention, this is a repeated and it is raised to the 2, so for that we have this extra partial fraction x to the 2 plus 4 to the 2, and of course in the top we have to put fx plus g. If this was power 3, then we had to add x to the 2 plus 4 to the 3, and of course hx plus I here. But because it is raised only to the power of 2, so we don't need this here. So this big expression here, all of this expression is the partial fraction decomposition form for this rational function. And as you can see here, we have a, b, c, d, e, f, and g, which are basically 7 coefficients, 7 unknown coefficients, which we have to find. But usually for questions like this, we use a software, and doing this by hand is not really easy. Let's do another example. Here we have x to the 2 plus 9 over x to the 2 minus x times x4 plus 6x to the 2 plus 9. Before we start, first we have to factor the denominator. X to the 2 minus x can be written as x times x minus 1. What about this? If you pay attention, here we have just x to the 4 and x to the 2. So you can think this as x to the 2 plus 6x to the 2 plus 9. This is like a quadratic function. So basically you have to guess two numbers that their product is 9 and their sum is 6. Those numbers are 3 and 3. 3 times 3 is 9, 3 plus 3 is 6. So we can factor this in the form of x to the 2 plus 3 times x to the 2 plus 3. But x to the 2 plus 3 times x to the 2 plus 3 can be written as x to the 2 plus 3 to the power of 2, because it's multiplied by itself. Instead of writing x to the 2 plus 3 times x to the 2 plus 3, simply we write x to the 2 plus 3 to the 2. Now that we have the factored form of the denominator, and of course we have to write the numerator, we are ready to write the partial fraction decomposition form. A over x plus b over x minus 1 plus cx plus d over x to the 2 plus 3, and finally ex plus f all over x to the 2 plus 3 to the power of 2. This is the partial fraction decomposition form for this rational function here. This is our answer. Now look at this example. we want to write the partial fraction decomposition form, and in this particular example we are going to find the coefficients. First, note that the denominator is already factored, and of course we always check that the degree of numerator is less than the denominator, because otherwise first we have to do the long division, then for the remainder over the denominator we have to do the partial fraction decomposition. But here the degree of numerator, what is the degree of polynomial in numerator? 4. What is the degree of the denominator? In the denominator we have x times, in this bracket we have x to the 2, which raises to the 2, and x to the 2 to the 2 would be x to the 4, and if you multiply these it's x to the 5. So if we expand the denominator, the degree of denominator is 5, but the degree of numerator is 4. So the degree of numerator is less than the denominator, so we don't need to do any long division. We are ready to write the partial fraction decomposition form, which would be a over x plus, can you guess the next step? bx plus c over x to the 2 plus 1. And because it's repeated, so plus dx plus e all over x to the 2 plus 1 to the 2. So this is the partial fraction decomposition form. We have 5 unknowns. For finding these unknowns, we multiply the left side and the right side of this equation, left side and the right side. We multiply both sides by, so we multiply both sides by x times x to the 2 plus 1 to the 2, basically by this. Because when we multiply left side and right side by this expression, we can get rid of all of the denominators. If we multiply this, all of this fraction by this cancels with this, and what remains in the left side? Then we have 5x to the 4 plus 7x to the 2 plus x plus 2 in the left side. But what we have in the right side? When we multiply this in this bracket, we have to multiply in each fraction individually. When we multiply by the first fraction, what happens? This x here with 1x here cancels. So what remains? We have a times x to the 2 plus 1 to the 2. When we multiply this in the second fraction, we have bx plus c times by x times by x to the 2 plus 1. Attention, when we multiply this in this fraction, 1x to the 2 plus 1 with one of these cancels, so 1x to the 2 plus 1 remains. So we have this. And finally, when we multiply the last fraction, this by this completely cancels with this, and only we have dx plus e times x. So we have dx plus e times x. Let's expand the right side. We keep the left side, 5x to the 4 plus 7x to the 2 plus x plus 2. In the right side we have a times x4 plus 2x to the 2 plus 1. In the right side, when we expand, we have bx to the 2 plus cx. We multiply this in the first bracket, and we get this times by x to the 2 plus 1. And if we multiply x in here, we have dx to the 2 plus ex. Maybe you wonder why I multiplied x in this bracket. Can I multiply x in the other bracket? Yes, of course. It's multiplication, and the order of multiplying the brackets doesn't matter. Anyway, you multiply these brackets by each other, the answer at the end is the same. Finally, we have 5x to the 4 plus 7x to the 2 plus x plus 2 equals ax to the 4 plus 2ax2 plus a plus bx to the 4 plus bx to the 2 plus cx to the 3 plus cx plus dx to the 2 plus ex. As you can see, this question has a lot of calculation and you have to be careful not to make any mistake. 5x to the 4 plus 7x to the 2 plus x plus 2. Now I am going to factor similar terms. Attention, we have ax to the 4 and bx to the 4, so we can write it as a plus b times x to the 4. Now look for the terms with x to the 3. We have only one term with x to the 3 and it is cx to the 3. And then we look for terms with x to the 2. If we look for x to the 2, basically we have 1, 2, 3 terms with x to the 2. And if you factor x to the 2 from those terms, then you have 2a plus b plus d times x to the 2. What is coefficient of x? If we check, you can see that the coefficient of x is c plus e times x. And what is the term that is constant? If we look for a term that is constant, is only this a here, which is without any x. So plus a at the end. Now, by comparing corresponding terms, the left side with the right side, we can find a, b, c, d, and e. Pay attention. What is the constant term in the left side? It's 2. What is constant term in the right side? It is a. So a is 2. Now, compare coefficient of x to the 4 in the left side with coefficient of x to the 4 in the other side. A plus b is 5. And because a is 2, so 2 plus b is 5, so b is 3. Now, coefficient of x to the 3 here is c. But in the left side, we don't have any x to the 3, so c is 0. Because in the left side, we have basically 0 x to the 3. We have no x to the 3, so it's 0. So c is 0. Now that we have a, b, and c, let's compare coefficient of x to the 2 here with coefficient of x to the 2 here. In the other side, it's 7. In the left, the coefficient of x to the 2 is 7. So 7 should be equal to 2a, but a is 2, so 2a would be 4. Plus b, b is 3, plus 3, plus d. So from here, d is 7 minus 7, so d is also 0. And finally, compare coefficient of x in the left side with the right side. In the left side, coefficient of x is 1. We have 1x here, but here is c plus e. So c plus e should be equal to 1. So we have c plus e equals 1, but c is 0, so e equals 1. d is 0, c is 0, a is 2, and b is 3. Now that we have all the coefficients, we can plug in these values in the partial fraction decomposition form that we had. So a is 2, so the answer is 2 over x plus bx, which is 3x, c is 0. So just 3x over x to the 2 plus 1. dx, d is 0, but e is 1, so 0x, we don't need to write 0x plus 1 over x to the 2 plus 1 to the 2. And this is the final answer for the partial decomposition form of this expression. I hope by watching this video you have learned about partial fractions. If you like this video, please subscribe to my channel and watch my other videos about partial fractions to learn more about using them for integration of rational functions. Thank you for watching.